folks. Welcome to Vector Calculus. Today we're going to be taking a look once again at the cross product. More specifically, we're going to be taking a look at how to find the unit vector which is orthogonal to two given vectors. What do I mean by that? Well, it's always good to draw a picture when you have these kinds of problems. What I mean by that is given two vectors, given two vectors A and B, we're going to be asked to find a third vector that's not only orthogonal, not only perpendicular to both of our vectors, but it's also a unit vector, meaning that it has a magnitude. What's the magnitude of a unit vector? Well, you guessed it, it's a unit vector, so its magnitude is going to be 1. So our goal is going to be, given two vectors A and B, we have to somehow find a third vector which is not only perpendicular to both of our original vectors, but it also has a magnitude of 1. So how do we do this? Well, first and foremost, let's go ahead and write down what our two vectors are. So here's our two vectors. Do we have our two vectors right here? Let me go ahead and write down what our two vectors are. We have A is equal to 4i hat minus 3j hat plus k hat. And we have B is equal to 10i hat minus 9j hat plus 2k hat. Okay, great. So now we have two vectors here, and they're vector A and B, right? We have two vectors here. So let's visualize this. Here's vector A, here's vector B. What's our goal? What is our goal? You have to always remember what your goal is. Your goal here is to create a third vector that is perpendicular to both of our original vectors. So let's call that third vector U hat. Okay, good. So now how are we going to find this third vector U hat? Well, the key is going to be using a familiar operation. It's either the dot product or the cross product. You know that. But do you know which one to use? Are you going to use the dot product here? No. The dot product is used to tell you how similar two arrows or two vectors are. You can also use it to find angles between two vectors or the magnitude of a vector. But you cannot use the dot product to find a vector perpendicular to two vectors. You can use the dot product to find a vector perpendicular to one vector, but not two. That's where you need the cross product, okay? That's why we're going to take the cross product of A and B so that we can get this third vector orthogonal to both U and V, to both A and B. So let's go ahead and take that cross product. Okay, so what is A cross B going to be? Well, hopefully you know by now. To take the cross product of two three-dimensional vectors, we have to set up some kind of a matrix. Right? And the matrix is going to have 3 rows. First row is always going to be your unit vectors in the x, y, and z direction. I hat, j hat, k hat. Second row is going to be the components in the x, y, and z direction of your first vector. So it's going to be 4, negative 3, and 1. 4, negative 3, and 1. That's going to be the components of the x and y and z of vector A. Likewise, we're going to list the components of vector B, 10, negative 9, and 2. Okay, so let's find the cross product from this matrix. How are we going to do that? Well, hopefully you recall, to find the cross product, let me color code this. We're going to look at I hat, isolate the column, isolate the row, circle I hat, circle the isolated square matrix. So let's go ahead, put that down. I hat times this square matrix, which is negative 3, 1, negative 9, 2. There it is. There's the first determinant we've got to calculate. Let's put down our second determinant. So I'm going to rewrite all of that so that we can kind of do the same color coding process again. So I hat, j hat, k hat as our first row. 4, negative 3, 1, components of our first vector as the second row. 10, negative 9, 2, components of our second vector as the third row. So what is our second determinant going to be? Let's use a different color. This time I'm focused on j hat, so I'm going to isolate the column, isolate the row, circle j hat, and circle the isolated square matrix, right? So by rule, by convention, I have to subtract j hat and let's put down the square matrix that j hat isolates. 4, 1, 10, 2. So 4, positive 1, 10, positive 2. And finally, let's use dark purple for our final isolation. And what's our final isolation going to be? Well, first let's rewrite our matrix again so that we can do the same color coding process. So I'm going to have as my first row I hat, j hat, k hat. My second row are going to be the components of my first vector, 4, negative 3, 1. My third row, my final row, my last row, are going to be the components of my second vector, 10, minus 9, and 2. So now I've done I hat, I've done j hat. My focus now is not on I hat, not on j hat, but on k hat, right? So I'm going to isolate the column, isolate the row, circle k hat, circle the isolated square matrix. So now I can go ahead and put this down here, plus k hat, and plus k hat, and let's put down the square matrix we're hoping to find the determinant of, right? What is that square matrix? Well, it's going to be a 2 by 2 square matrix, we know that. So we're going to have 4, negative 3, 10, negative 9. 4, negative 3, 10, negative 9. Okay, now we're ready to compute these determinants. So our first one is going to be I hat. What's going to be the determinant of this square matrix? Well, do what you used to do, right? You're gonna take your two diagonals, find the product of the first diagonal. So minus 3 times minus 3 times 2. Subtract that from the product of the second diagonal, 1 times negative 9, and you're good for that one. How about j hat? Let's get green here. Where's green? So we're gonna do for j hat minus j hat, and what's our determinant gonna be here? Well, here we're gonna have our first diagonal, which is gonna be 4 times 2, minus our second diagonal, which is gonna be 10 times 1. It doesn't matter if you do 10 times 1 or 1 times 10. Multiplication is commutative, so you don't have to bother about that. A lot of people ask that question, so good to address that. Finally, for our third determinant, what we're going to have is our first diagonal, 4 times minus 9, minus our second diagonal, 10 times negative 3, 10 times negative 3. And so what do we end up with for our final answer? Let's see if we can get this down in red, because, oh wait, no. So for our final answer, we'll have negative 6 plus 9. So what's minus 6 plus 9? Minus 6 plus 9 is 3 I hat. So here I'm going to have 4 times 2 is 8 minus 10. So 8 minus 10 is minus 2, but here's a minus sign. So plus 2 j hat. And finally here I'll end up with minus 36, 4 times minus 9, negative 36 plus 30. So 30 minus 36 is minus 6 k hat. We're almost done, but don't leave yet. Because remember, I want a unit vector. You see this hat on top of the u? Tells me I want a unit vector. So I'm going to have to divide this cross product by the actual magnitude of this vector. And what's the magnitude of this thing? Well, magnitude, remember, is going to be the square root of the square, sum of the square of the components. Right, so what's that going to give us? Well, let's see. Here I'm going to have 9 plus 4 plus 36. Okay, so 9 plus 4 plus 36. 9 and 4 is going to give us, actually I can't math anymore. Okay, so 9 plus 4 plus 36 is going to give us 49. So the magnitude of our cross product is going to be 7. So divide each component of the cross product by 7. So instead of 3, I'll have 3 over 7 I hat. Instead of 2, I'll have 2 over 7 j hat. Instead of negative 6, I'll have negative 6 over 7 k hat. And finally, remember, there's not just one perpendicular vector, there's 2. Another one going down that way. So we're going to have to put a plus minus sign, and we're done. This is the unit vector perpendicular to our original 2 vectors. Ladies and gentlemen, that's it for this lecture on vector calculus. We'll check you out next time.
embedded plus MKO plus scaffolding equal lower. Excuse me. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.